Hello, everyone. My name is Baldev Krishan. I'm the founder and CEO of iVALT. I have with me Brian Stout, who's the co-founder and chief product officer. And we'll get started in a minute or so. We're waiting for other people to join in. And today we're going to talk about two, two topics. How do we combat AI with our solution, with our on-demand ID? And also how we deploy AI for the endpoint identity. So these are the two things we're going to be talking about, and Brian will go through the details. We will appreciate any feedback, and any inputs will be greatly appreciated. And toward the end of this presentation, Brian will show you how you can download the app and also try it out while you're listening to the presentation. So in any event, with that brief overview, I'm going to pass it on to Brian to get into more details of our AI offering. Thank you, Brian. It's all yours.
Okay, thanks, Baldev. I'm Brian Stout. I am the co-founder and chief product officer at iVALT. And again, I thank you as well for joining us today. As Baldev mentioned, we're going to cover two topics. The first topic is really how we stop AI attacks. And we've done this already. AI, of course, makes everything more difficult, and I explain how we get around that as well. And then also how we can use AI to create strong protection at the endpoint, even as AI evolves, which is an important concept as well. Our fundamental approach to identity fits perfectly with the way the world is going with decentralized, mobile-centric identity verification. And this is a big benefit in being able to neutralize AI attacks and the threats that are coming and giving users more control over their identity. And Baldev and I have been working at this for 6 years. We've been able to pivot along the way as the market has really come to the conclusions that we've started out, sort of our precepts of what we believed this was going to be. We've talked to hundreds and hundreds of people, and we've been able to come to the place where we believe what we have is truly the future of identity. Okay, so first of all, the question really that solves most of the cyber security problems is the fact that we don't really know who's at the endpoint. And we try to identify the endpoint. In many cases, all we're doing is identifying a device, a set of credentials, and it's not really identifying who is using those credentials of that device. And the fact is that AI is creating fuel for all types of hacker attacks. And so fundamentally, this breaks down into first, what happens when you add AI is you get more efficiency. So a lot of the attacks that hackers are taking right now, it's work for them to do that. And if you use AI, you get a much faster scale. They can hit many more people much more quickly. It's easier to target by capturing information specific to that person that makes it more believable. And then it's a better ROI. So if you're a hacker, you're very aware of how much time you're spending and what the reward is. And the other big problem is stolen credentials, which is primarily what hackers get through phishing attacks, etc. Really empowers 80 to 90% of cyber attacks. And these are what fuel things like identity theft, ransomware, and breaches, data breaches. So even if you start to use things like biometrics and others, that slows that process down. But a lot of the processes that are in place now that are traditional authentication are being hacked slowly in very creative ways by hackers. The second piece is the effectiveness of the attacks. And the attacks are really, because you can use AI, the attacks are much higher quality. So the data that's captured about you and about a lot of people all at the same time using AI tools, the messaging is very relevant. There can be references to people you know, to events that have happened, et cetera, by being able to capture this information using AI and then customize the attack. So this makes it much easier for attackers to get access and get the information they're trying to get. And this, of course, leads to AI deepfakes, which is essentially the next generation of social engineering. So the AI deepfakes is just using AI tools to further create a compelling impersonation of you. It can sound like you, it can be coming from what seems to be a reasonable location, etc. So there's a lot of motivation here to push this forward. And the only way to attack this, really, we think, is with innovation and also by fueling that innovation with AI itself. So we're essentially creating a circumstance where it's using AI to attack AI, if you will, or to protect against AI. Okay, to stop AI attacks, one of the key points is understanding that we have to control our own identity. For a very long time, we've been delegating the protection of our identity to hundreds of companies that we have relationships with. You're asked to create credentials, a username, which is typically an email address, which we use many, many times for very many different types of applications, and then passwords. And a lot of times we get lazy and we use the same password. So we've got to make this a situation where users can actually control their identity and take that delegation out of the equation and make it a situation where everything has to come back to the user to inform the decision on whether to connect or not. So there needs to have the ability for the user to control their own identity. And just to point out again, AI is a tool and it can be used by hackers, but it can also be used for good here. And so we're going to talk a little bit about that. First of all, our vision is that outrunning AI with technology is a parity game at best. And this has been what's going on in identity for years. We created passwords, passwords were stolen, we created multi-factor authentication, et cetera. All these things get hacked in one way or another, and so it's constantly fighting the hackers, and it's a constant parity fight. So the solution is really not technology. The solution is to make the attacks inefficient and ineffective, which in turn drives down the hackers' ROI. So if they can't make money and it's not effective, they're going to move on to the next target. And so it's not unlike having a security system sign in front of your house. The burglar goes next door where there isn't that difficult way in. And then the second thing is to make the scale impossible. They can't go steal 10,000 names, capture all the information about those 10,000 people, and launch a massive attack. It has to be something in the equation that makes it hard for that scale to happen. And that's what we do. So the solution, fundamentally, we talk about 5 factors of identity, but it's much bigger than that. And the idea is you take, at the mobile point, you capture biometrics, and this can be any form of biometrics, the device ID, which is unique for every device on the planet, a unique code that is tied to the user, but also to the application they have permission to access, and then GPS in time, which creates very tight windows around geofencing, which, if you think of it, it can be my geofences for my bank account, could be my home, my office, and my favorite coffee shop, and only during business hours in Colorado where I live. And when you start to narrow down the attack surface using this approach, it gets very, very difficult to hack. And we've had red hat hackers look at this, and they're pretty convinced too that this would be very hard to hack. And especially when you go to up to 25 factors that can be captured. And you see all these in the gray boxes, and they break down into the categories of network attributes, which are different for every authentication and for every user. What's the proximity now? What's the Wi-Fi's? What Wi-Fi's can you see? And what are the strengths of those Wi-Fi's? That's a very, very accurate, almost GPS strength location. So the strength of the Wi-Fi in my house and the various Wi-Fi's I can see and Bluetooth and other things, those all create other signatures around my identity. And then there's a lot of environmental data that can be looked up. And this can be where I am right now, but it can also be any city on any day at any time. So it could be my favorite city or the city I was born in. It can be 3 days ago, 10 days ago, last month. And then last of all is financial numbers, such as the closing price on a stock or crypto or the indices on a particular day. Okay. So hackers would have a hard time understanding what day, first of all, and then the data that's being captured would be a mystery, and all that would be seen if there was any kind of a man in the middle attack is just a bunch of numbers. They wouldn't know what those numbers were. And then if you look at the math on this, if you have 25 factors, that's 33.5 million combinations of factors alone. So if those are uniquely assigned by use case and by user, then and each of these also has up to billions of potential values for each factor. This is an enormous problem to solve from a hacking perspective. And this creates the highest possible security for endpoint identity. And endpoint identity is really what we're looking for in everything you're trying to do in cybersecurity. So AI attacks are exponentially growing. It's been amazing to see in the last 6 months to a year or thereabouts how fast AI has been growing and how everyone is using it. What's interesting here is these AI attacks are not limited to human beings. And this is a really important point that it's not just humans, it's also IoT devices, it's AI agents which are coming in at lightning speed right now and anything in the future. And the important point is that it has to be solved by a single platform. So what we've done is we've created a single platform that can take multiple forms of identification from each of these entities. And the question really becomes, instead of who is really at the endpoint, it's really who or what is at the endpoint. And we can solve both of those, and our approach is to capture 5 or more factors of identity at every endpoint. So it's not simply the device ID or a certificate. It could be other attributes of that device. And the same is true with agents, when they're created, who created them, when they were created, where they were created, etc. That information can be used as a part of a next generation MFA, if you will, for not just the humans, but for the identity, for the agent identity, and then for IoT devices. And so all of these things are at risk. So all these combinations, AI agents need to identify the person accessing them, and the human has to identify the AI agent, et cetera, et cetera. And so it starts at human to human, which I'll show in a second here. And then it goes all the way down this whole list, and all these combinations have to be handled, and we handle them in a single platform using the same methodology. Okay, so I'm going to start. The first use case I'm going to discuss here is stopping AI-enhanced fake communication. So fake communication has been around for a long time. People call you up, they tell you there's somebody they're not. They tell you from some sheriff's department and then you owe them money or something. All these things happen. And there can be fake texts, answer this text, you're going to lose your car, or whatever it is, doesn't matter. And then online chats, who are you really talking to? You don't know for sure. There's no way to know this. So even though they're unknown, or even you think you recognize them or they seem familiar, this is still a problem because you don't really know. And so if using iVALT, you can ping iVALT. And of course, this assumes that within the ecosystem of people that you are communicating with, they all have the ability to use iVALT. So you can say, hey, I think this is you. I can say, Baldev, I think it's you. It sounds like you. This could be a deep fake. We're going to discuss a lot of stuff about our business strategy. Let's just make sure it's you and me. And so we verify each other. So I send a verification. It sends a push notification, and we get real-time identity. And applies to a lot of different use cases, things like friends and family, coworkers, customer service. Is that person calling you from your financial advisor actually from your financial advisor, or is it somebody trying to fake that person? And then help desks, of course, this is what drove the MGM attack back in the beginning of last year when someone impersonated the CEO and called the help desk. And because they had a lot of information about the CEO that they'd captured online, they were able to convince that person to change a password. And the next thing you know, you had a $100 million ransomware attack. So being able to do this is really important on a lot of levels and in a lot of combinations of people talking to each other or communicating with one another. So this push notification comes back. It's a one-click response back. And we collect the identity factors at the endpoint, whatever those are, and I'll get to the selection of those in a minute. And all the relevant factors are verified by our authentication engine. And then there's a identity is verified back to the person at the other end. So I know that the person I'm talking to or I'm in a text thread with or I'm online with is actually who they say they are. And so what this does is it stops social engineering and AI deepfakes today. And this is only worse as AI gets stronger and stronger, but our methodology solves this problem because we're not relying on a technology approach. We're relying on a number of factors that have to be proven at the endpoints. So irrespective of what technology is being used by the hackers using AI. Okay, the second use case here is how do you stop the use of stolen credentials? Somebody steals the credentials and they're trying to use them. And so you see on the left-hand side, these are people trying to gain access, and it could be, you know, someone in an office, it could be someone out in the public somewhere, it could be a hacker. And these could come from a computer, a phone, it could come from a keypad. I'm trying to enter a building. It could be a kiosk where I'm trying to identify myself for whatever reason, or it could be NFC to use with a to get into a building. And so this request would go to the enterprise, and then the enterprise interface here, the different use cases would be, it could be identity and access management, multi-factor authentication. It could be CIBA, which is client-initiated backchannel authentication, which is using a mobile number instead of username and password for a whole variety of use cases that you can't use traditional usernames and passwords for. It could be physical access, as you can imagine, with keypads. It could be IoT devices. It could be AI agents, and it could be on site. An example is you go in to rent a truck at Home Depot and they ask for your driver's license. Well, they don't know if it's your, you know, if it looks like the person, they just enter it in. If it's a valid driver's license, you drive off with the truck, even if you're not the person. So doing a real-time authentication at that point on a mobile phone in front of the agent gives you the ability to prove your identity separate even from the systems that they have in place. Okay, so those are the use cases. We have APIs. It goes to iVALT. iVALT pushes the notification to the person who might be just standing there or they're at a kiosk or on the phone. Uh, there's a simple UI that we have. You can see the picture of the three screenshots there. It's a one-click response. The factors are captured. They're sent back to iVALT, and iVALT verifies the factors based on what that profile is for that use case, and then the identity is verified and access is granted. Now, this process stops stolen credentials because if you steal credentials, you cannot do this because you have to be registered on your mobile device. It has to be the right device ID. There are geofencing things that can be put in place. So this is impossible to just steal credentials and get access, even if you use AI to steal those credentials and accelerate the attacks. It doesn't help you in the use of stolen credentials. Okay, so the building blocks, what does it take to do this? First of all, we have a downloadable mobile app, and I encourage you after this call to just go to the app stores and download iVALT, I-V-A-L-T. And it's very straightforward. You just enter your name, your mobile number. There's a verification of your mobile number. You enter your email address. You have to verify a valid email address, and then you'll be set to go. And then there's an icon that you'll see that says on-demand ID. If you click that, a screen will come up. You can enter your own mobile number in that screen and hit send, and it'll ping your phone. Click on that. You'll be able to, it'll take Face ID and it will return attributes from the endpoint. So it'll be a verification of your biometrics. It'll be a verification of your device is the registered device that you had just done a few moments before. And it will give you the time, which we can use for geofencing and time windowing, and your location and the application itself to know that you had permission to use that application. So this is all can be done without any infrastructure changes, which is really important in an enterprise environment. This can be used for help desk, et cetera, without having to be integrated fully into the IAM or the identity and access management system. Or we have available the ability to do full enterprise IT integrations. We have everything set up on Open API and NPM for the libraries. And then we've done integrations with Okta. We're working on SIBO right now with Okta and Auth0 and Ping identity. And so this is really important to understand that we can do it either way, but there's a large amount of value that we have without doing this as a complete integration into the infrastructure. So you can download the app right now, have someone else download it, and you can exchange informations and understand how this would stop social engineering immediately using just our just the app and the SaaS tenant that we have on our platform. And then also there, as you see in the middle of the page, there is an admin portal. So one of the services we provide is you can create an ecosystem or a set of users, say in a company, and have full control over those users and be able to add them, delete them, add geofencing, take away geofencing, et cetera, to be able to control those users in real time. Okay, and then last of all on this slide is the question comes up, well, this is all great, but if the data gets intercepted, there's a potential for being able to hack in. Well, we have partnerships with quantum resilient encryption companies to protect both the data at rest, so the information that we capture, and also their information by the same token. And then the communication pathways to make sure the information being passed can't be caught on a proxy server or something in the middle in a man in the middle attack. So we have the ability to add all of this in. Okay, so how do we do the AI defined identity piece that we talk about? And this is dynamic and it optimizes factors. So if you look at this chart on the left-hand side here, is you have to start with a set of AI defined preset variables, if you will. What are the things you're going to look for each use case? Because use cases vary all over the place depending on what you're trying to do. It's like access into a building is very different than logging into the accounting system. So it depends on what you're trying to do. And so what we do is start with something and then do some verifications. And then at the same time we do the verifications, we capture all the factors that are available at that point in time. And then we use that information in machine learning models to optimize what are the most useful characteristics for verifying identity. And it may be the ones we started with, there may be some slight modifications, there can be thresholds, etc. And then we modify based on that, and then there's just a constant optimization cycle. And so how this works is we start with presets and then we iterate using machine learning. And what this does is it creates the value of being able to find the most effective factors. First of all, you can start with a pretty good set based on AI, and then establish thresholds. When do we need to escalate based on certain risk factors? You can pull in some of the history, which is helpful also. Where does this person usually log in from? And if it's a deviation, then escalating and verify a few other factors. And then establish thresholds for that. And then look at the historical impact, as I said before. And then for any new use cases, start with presets and start this cycle all over again and be able to optimize for this new situation. And then last of all is pick dynamic variables that are useful. So when I say dynamic variables, these can be things like the high-low temperature in your favorite city last Tuesday, and those things, as I mentioned before. And these variables, when you add this in, and several of them, in fact, it's impossible to guess what those are. And so that creates a very strong user participated set of variables that can be added to the identity equation. And again, this is for human ID, can be used for IoT devices and AI agents, and then it's unique for each use case. So this is never a one size fits all. So it's a customizable approach for everything. So these are products that we've built on our platform. So using the fundamental approach that I showed earlier, the first thing we talk about is on-demand ID, which is real-time identity. This is what stops social engineering and AI deepfakes. So I want to identify you, you have the app, I ping you, you're my business colleague, you ping me, we identify each other, and then we have our proprietary conversation. DocuID is a very exciting new product that we are offering, and we'll probably do the next webinar on this. But the idea is if you're using a mobile-centric approach to identity, we can embed the mobile numbers that have been verified and have been identity proofed into documents. So when you save a document in Microsoft Office 365, for example, or even on the web, a document that's on your computer, you can upload that, and as one of the steps in it is you put in the mobile numbers of the people that you want to give access to, and then it pushes that, encrypts that, and pushes that to the cloud, and those people will get emails or can get access to it, but only those people they're the only people on the face of the earth that can unlock that document. So what people like about this is you have kind of a double, I call it a double wrapper. You're wrapping your database with standard encryption, and you use, our access for the IT guys, which makes that a lot stronger. And then each individual document also has identity restrictions on who can actually look at those documents. So if you have an exfiltration breach where the database is breached and a hacker steals it, there's multiple layers of protection on each individual document. And then we have universal biometric ID. This is how we do identity and access management for next generation MFA, and then for CIBA, as I mentioned before. And then we also have done AI agent identity, unique identity, IoT devices, electronic locks, and streaming devices. So all of these can be controlled by our basic platform, and we have IP around a lot of these things. So we'd love to talk to you about all of these if these are of interest, and how we could implement these for specific use cases you might have. So the summary is that we can do definitive identity. We can stop the AI attacks. We use AI in a way to strengthen the protection. And then it's a frictionless user experience. It's one click. So basically, we verify identity, and then we capture the rest of these variables passively. So it literally is a one-click experience. No typing 6 digits. None of the other two-factor authentication inconveniences. It's very easy to deploy, as I showed you. A lot of it doesn't even require infrastructure. The end user's in control, and it's a very easy path to passwordless. As you can imagine, this solution can be a standalone without using usernames and passwords. And we have some strategies for simplifying RBAC and ABAC within identity and access management. That's another conversation that if you're interested in, please hit me up about that as well. And that's future-proof because we use what's the best technologies that are available in the market, and we can add them in as soon as they're prolific enough that they can be used with the average user. Anybody can get access to them. And then any new attacks, we can modify everything on our platform to adjust for those. So thank you very much for your time. We have some information here, Baldev's contact information, my contact information. Please download our app, as these are the QR codes here. If you can snap those right now, that'll take you to the App Store. Please give us feedback on the app. It should be fairly straightforward on installing it. And then on the right side, it goes to our website, and then you can contact us via our email addresses here or by info@iVALT.com. And we'd love to hear your feedback on how you do authentication, what are the challenges, how this might help, where are areas that that our approach to identity verification could be of great benefit, and even new product development of things you might be working on that we could incorporate what we have into your product development cycle. And as I mentioned before, we have the open API approach that should make that fairly straightforward. So thank you very much for your time. We really appreciate it. Thanks.